The Gaussian model. The Gaussian model is actually, in a sense, a bell-shaped curve. And this is used a lot in statistics to represent populations what they call normally distributed. And for standard normal distributed, the model is, that's the answer for standard, a normal standard one. That is the actual formula right there. 1 over square root of 2 pi e to the negative x squared divided by 2. Notice you have a whole bunch of constants up here. This a would be 1 over square root of 2 pi. Notice you have the negative, you have an x. There's no particular x minus b in this one. The b would be 0 in this particular problem. And the c would be the 2. All right? And that's what it looks like. That's what that particular bell-shaped curve looks like. Now, here it is kind of grown up, and what I want to show you about a bell curve is this. And this is a little bit about statistics, so you can learn a little bit. That right there is what they call one standard deviation and covers 68% of the population. In other words, a little over 2/3 of the population, this is considered to be average. 34% above that number to there. That number there would be 1. That's one standard deviation. The 2/3 of the population is average. All right? Now, from this -2 to 2 in a standard curve represents 95%. That's 95% of the people fall within 2 deviations of the average. All right? So, what I want to look at is this. How can I find that percent? Well, first off, what's 95 minus 68 divided by 2? And that's where you get the 13.5. Now, from this would actually be a -3 to +3, pretty close out here. It's not quite numbers, remember, not quite right, is 99%. And what happens is, that means I have 2% added on right there. Only 4% of the population is more than 2 deviations away. Or I should say 5%. 5% because it's 90. And less than 1% hits like way out there. That's way out there because this is average. This is just a little above average. This is your valedictorian type people are here, and these people out here are your super geniuses like Einstein. Kind of to explain what that bell curve means. That's what the bell curve means. All right? Now, here's our actual problem on the Gaussian model. The SAT test followed a normal distribution. Here's our numbers, our A, there's our B, notice it's squared, negative, and there's our C term. For X, when X is between 200 and 800, because those are the scores range usually for the SAT, all right? For numbers between 200 and 800. I'm going to go to my calculator, and if you would, set your calculator to your windows, the minimum of X minimum of that, X max of that, a Y minimum of 0, a Y max of 0.004, your X scale could be 100 and Y scale 0.001. Otherwise, your graph will not look correct. Whoops, sorry, kicked the camera. Got excited about that. All right, putting it back. Go to your calculator, and what I want to do is I want to find the average right there, that point there. And I'm going to do that by graphing it, by putting Y equals in my calculator, that window, and do second calculate, option 4, and I got to hit enter with my arrow on this side of that line, move it over, right, enter right there, enter again, and it will tell me that the average score, this is the number I'll get, 516 at 0.0035. So when Y is 0.0035, X has to be 516, meaning the average score on the SAT test is 516 in the year 2002.